All right, so another day of quadratics. Second day, we're going to cover some of the more complex problems today. Again, this is mostly just going to be what we did yesterday, but they're just not going to simplify quite as nice as they did yesterday. So again, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, it needs to be in the quadratic form before you can actually use the quadratic formula. So you got to have everything on one side equal to 0 before you can start. Okay? So again, I've got a problem set up kind of like I did yesterday, which I could solve using square roots. And I'll show you how to do that in a second, but I'm going to again start off by just plugging it into the quadratic formula to start with. So there's no b term here, so this bx is gone, so that's 0, right? So to set it up in the quadratic form, it would be 0 plus or minus the square root of 0 squared minus 4 times a, which is negative 12, right? Because this is a and this is c. And then times c, which is 9. Okay, and then all over 2 times a, which would be 2 times negative 12. Okay, so again, the zeros kind of just go away. Negative 4 times negative 12 is positive 48 times 9 is 432. So I have the square root of 432 being plus or minus being divided by negative 24. The square root of 432 is 12 times the square root of 3. So not as nice, right? So I have 12 times the square root of 3 all over negative 24, plus or minus, right? Well, this is where you have to do some simplifying, right? This 24 could be split up as 2 times, or however you want to write it, well, let's split this up into positive and negative, so it'll be easier. So 12 square root of 3 being divided by 12 times 2. Negative 12 times 2, sorry. And negative 12 square root of 3 being divided by negative 12 times 2. Okay? So the reason I split up that bottom into common factors is because we can cancel out common factors that are multiplying, right? So we could cancel out these 12s on both of these. Now this leaves a negative up here. So x could either equal negative square root of 3 over 2. And then the negatives would also cancel out down there, leaving x could equal a positive square root of 3 over 2. Okay? So those are your two possible answers. And I just realized I forgot to write equal to 0 there, but hopefully you guys figured out that that was supposed to be there. Now, if you wanted to do this using the square root method, you could, right? Because if I were to do this normally, so I'd have to minus the 9. It's going to be more difficult this way. Negative 12x squared equals negative 9, and then you divide by negative 12 because that has to be by itself before you can square root. And then that's going to simplify to x squared is equal to 3 over 4. And then you square root both sides, and x could either equal a plus or minus square root of 3 over 2. Right? Because square root of 4 is 2. Can't simplify square root of 3. All right. Let's try another one. So we're left with these, rational answers here. But that's fine. We're going to get all those today. So in this next problem, I have the issue of it not being equal to 0, so I have to start by adding 6 to each side. So that gives me 6x squared minus 10x minus 2 equals 0. Okay, now I can identify my ABC, so A, B, C. And then I plug those into the quadratic formula. So B is negative 10, so negative B would be positive 10, plus or minus the square root of negative 10 squared is 100, minus 4 times A, which is 6, times C, which is negative 2. And then that's all being divided by 2 times A, or 2 times 6, which is 12. Okay, so let's simplify this top. So negative 4 times 6 times negative 2 is going to be 48. So I have 100 plus 48, which is 148. So I have the square root, so 10 plus or minus the square root, 148 all over 12. Okay, so the square root of 148 is 2 square root of 37. So I'm going to rewrite this as 10 plus 2 square root of 37 divided by 2, and 10 minus, 12, 2 square root of 37 all divided by 2, 12. I don't know why I keep doing that today. Okay, so next thing I'm going to look for is if there's any common factors between these three terms. Okay, there's 3 terms here. I have to keep, these are technically 2 separate terms, right? That's the common mistake, is we can sometimes take it out of this first, the second one, but not both. But when you're taking out a common factor, if there's a plus or minus, those are 2 separate terms. So I can rewrite this 12 as 6 times 2, right? I can rewrite this 10 as 2 times 5. That means that 2 is a common factor in each of these. So I can take out a 2 out of both of these problems, which means x is going to either equal 5 plus the square root of 37, all divided by 6, right? Because I just took out the 2 from each of those, leaving 5 and 6. Or x could equal 5 minus the square root of 37, all divided by 6. And those are my 2 answers. That's as far as I can go. Okay. Let's try one more. I know this is going to be kind of a longish video, but let's do one more. Kind of get you guys some good practice on some of the stuff that you haven't seen. So first of all, I'm trying to make sure I wrote down right. Okay, so looking at this last one, it doesn't look like it has the b term, but it does have to equal 0, right? So I have to add 11 to each side, which give me negative 12x squared minus 11 equals 0. Now again, there's 2 ways we could do it. We could do the quadratic formula way, or we could do the solve by square roots. Let's try just by doing the solve by square roots, just to cut this video a little bit shorter. So to solve by square roots, we're going to add 11 first, which that would give me 11 there. And then I'm going to have negative 12x squared equals 11. Actually, let's use the Pythagorean theorem. It's going to be a little bit easier to use the Pythagorean theorem because this is going to require rationalizing with an imaginary number, which isn't super fun. So using the Pythagorean theorem, there's no b, so 0 plus or minus the square root of 0 squared minus 4 times a, which is negative 12, times c, which is negative 11. All over 2 times negative 12, which is negative 24. Okay. See, this way I don't have to rationalize anything in the denominator. It's just all in the numerator up there already. So it comes pre-rationalized. Remember, if you do solve by square roots, you can't have a square root in the bottom, so you have to multiply it to both the top and bottom to unsquare root it. Okay, anyway, -4 times -12 times -11. So -4 times -11 times -12, I don't know why I did that out of order, but I did, is -528. So plus or minus square root of -528 all over -24. Well, I cannot have a negative square root, right? So I have to take out the -1 square root, which is just I, imaginary number, right? So I would have plus or minus I times the square root of 528 all over -24. And then the square root of 528 is 4 times the square root of 33. So I have plus or minus 4i times the square root of 33 all over -24. Okay, not quite done yet though, because there's going to be some imaginary or some common factor here that I can take out, right? So if we think about it, there's a 4 here. I could rewrite this 24 as 4 times -6, right? So if I cancel out these 4's, I'm going to be left with 4, not 4. Let's do the positive I. So on one of these, the 2 negatives would cancel out. On one, the 1 negative would make everything negative. So I'm going to have either -I times the square root of 33 over 6, or I'm going to have I times the square root of 33 over 6 would be the 2 possible answers for X. And that is it. Sorry, that's a longer video, but that is the quadratics, the more not so nice ones. But again, it's just simplifying as much as you can and then stop. Make sure you're looking for common factors at the end. That's the biggest miss on these.